Okay, find the equation of the tangent at the point given on the circle for each of the following. So first circle here is x squared plus y squared is 25, and the tangent is at this point 4, 3 here. So remember now, the tangent is a straight line which touches the circle, okay, at one point, and we want the equation of it. Now I've drawn this. This was easy sort of to see because you know that here the center is 0, 0, the origin, okay, and of course you know the radius then is 5, okay. But the question is then, how do we get an equation of a straight line? And it is a straight line, okay, because it's a tangent. So it goes back to the work we've learned on coordinate geometry. Equation of a straight line is this, if you remember, yeah? You can write it like that. So we need a point, okay? Now we've got a point on the line, 4, 3. So my x1, y1, okay, will simply be that point there, yeah? Okay, we've got a coordinate, a point on this line, so we've got our x1, y1. What we need is the gradient, yeah, the m value. So how are we going to work out the gradient? How do we know the slope of this line? They don't tell us in the question, however we can work it out, and it's all to do with using the circle theorem, okay. And the circle theorem says that a tangent, okay, touches the circle so that it is at right angles to the radius. Okay, so I've drawn a radius in here, that there will be right angles. Okay, now if I can work out the gradient here, okay, right, of this, then I can work out the gradient of the line which is perpendicular to it. Do you remember that? Okay, so we've got a formula for that as well. So let's work out the gradient then of the radius. Okay, gradient of the radius that we have here, the radius to the point 4, 3. Okay, well, if you remember the formula for gradient, it is y2 minus y1, okay, all over x2 take away x1. So the difference in y's divide by the difference in x's. You might have remembered from GCSE, it's like the rise divide by the step, yeah. So the difference is in y's is like the rise, isn't it? Okay, how much it's increased by, and the step across is the difference in x's there. So we're going to do that. So we're going to have these 2 points here to work out the gradient of the radius to 4, 3. Okay. So you know, we can call that x2 y2 if we want, and then we can call the origin x1 y1. Alright, so then quite simply you do 3 take away 0, okay, y2 take away 0, y1, all over then x2, which is 4, take away x1, which is 0, so you get 3/4. So that's the gradient of the radius there, but we want the gradient that's perpendicular to it. So remember, if this is the tangent, this would be called the normal, wouldn't it? Okay, so we could just simply call that the gradient of the normal is 3/4. Okay, so how do I get the radius of the tangent, which is at right angles to it? Well, if you remember, we also have another formula for that, for when lines are perpendicular. So the normal is 3/4. So all you've got to do is take that 3/4 over and divide. Okay, flip this fraction, and then you get obviously then minus 4/3. So that is the gradient of the tangent. Okay, so going back then to my formula that I wrote up here. So y minus y1 is x minus x1. Well, my point on the line is that, yeah, 4, 3. So my y1 will be 3, the y value. Okay, the gradient is negative 4/3, and the point, remember, is 4, 3. So the x1 value will be 4. And I have that, right? So we can tidy this up a bit then. You know, you can think about taking that 3 over here at the other side and multiply through by 3. So 3y minus 9 minus 4x plus 16. And then maybe get everything onto one side. So 4x plus 3y, take that over, so you get minus 25 5, I think. If I've done that right, yeah, equals to 0. So there's the equation of my tangent.